An application to probabilities is something called expected value. And expected value is pretty much what it sounds like. It's telling us what to expect in the long run if a certain event is repeated over and over several times. It's kind of giving me an idea of what would the net result be. The way we calculate it is to multiply the possible outcome by its probability and then add those all together. That's pretty abstract, so let's look at an example to make it clearer. In a certain state's lottery, 48 balls are numbered 1 to 48, placed in a machine, 6 drawn at random. If the 6 numbers drawn match the numbers that a player has chosen, that player wins $1 million. If 5 of the numbers match, they win $1,000. It costs $1 to buy a ticket, and we're asked to find the expected value. So as a player, I'm going to spend $1. I could win $1 million, which the net result to me is going to be $999,999. The probability of that, you can see, is very small. It's 1 out of 12,271,512. We could also match 5, in which case I've spent $1, but I win $1,000, so my net result is $999. And the probability there is a little better. It's 252 out of 12,271,512. Or we could win nothing. We actually lost $1. A -1 is our net result. And the probability of that is 1 minus those others added together. So we come up with a very likely scenario. All right. 12,271,259 out of 12,271,512. So calculating the expected value means I'm going to take this outcome, the 999,999, times its probability, and I'm going to come up with 0.08149. I'm going to round to several decimal places here. We'll take care of rounding to dollars and cents at the end, but I'm going to take in several places just to make sure I get the most accurate answer. Then we take the next outcome times its probability and come up with 0.02051. And then we take the final outcome, which is we lose $1, times its probability and come up with a negative 0.99998. Now you can see why I use so many decimal places. So the expected value means I'm going to add up all of those values together, and we're going to come up with an answer that I'm going to round to 2 decimal places because we're talking money. And it's about 0.90 if I round to 2 decimal places, and it's negative. So that means in the long run, if I play this over and over and over, I should expect to lose about 90 cents every time I play it. All right. So in the long run, I'm losing money every single time. Here's another example. This is a more business-oriented example. A construction company is planning to bid on a contract. The bid costs the company $1,500. So in some cases, you actually have to pay money to get a chance to bid on a job. The probability that the bid is accepted is 1/5, 20%, not too bad. If the bid is accepted, the company makes $40,000. So yeah, they had to spend a little money, but they could earn potentially a whole bunch more. So we want to find the expected value and describe what that means. All right, so let's talk about this. The first thing is, what's the probability that they win the bid? 1/5. And what's the outcome of that? Well, they get $40,000, but remember they spent $1,500. So we're going to take 1/5 times the quantity of $40,000 minus $1,500 and come up with $7,700. It's positive, that's good. But they could also not get the bid, right? So the probability they don't win the bid is 4/5. And in that case, the outcome is you've lost the entire $1,500. So 4/5 times the negative $1,500 leaves me with negative $1,200. I add these two together and come up with expected value of $6,500. So what does that mean? Well, first of all, it's positive, so that's a good thing. If it's a positive outcome, that means a company stands to make money in the long run if they do submit bids for things like this. And so on average, they might make about $6,500 for each bid that they're submitting. But the biggest point is they're going to come out probably ahead, even if they have to spend money and lose. Sometimes overall, they'll come out ahead. Let me know if you have any questions.